All right, we'd like to look at solving logarithmic equations now. And so here's a logarithmic equation. We have log base 6 of x plus 2 plus log base 6 of x plus 2 equals 2. All right, now the way to solve a logarithmic equation is to basically isolate the logarithmic expression. That might require using our ability to condense a logarithmic expression using the three properties that we've seen before. Once we've done that, we want to use the definition of logarithms to write the equation in exponential form using the definition of logarithms, which we have here. And recall what that is. Log base a of x equal to y means that y is the exponent on a that gives us x. Written in exponential form, y is the exponent on a that gives us x. Recall log base a is the inverse to the exponential function of base a. So once we have this, we can write it in this form, and typically we'll have a number here, and that'll allow us to solve for the variable. Okay, so let's do that with this. So here we have two logarithms added together. They have the same base, that's good, equal to some number 2. Now we need to isolate the logarithmic expression, but there are two of them. So we need to combine them into a single one. And recall that if we have the sum of logarithms, we can write that as the product of the arguments. So we have log base 6 of x plus 2 times x plus 2 equal to 2. All right, now x plus 2 times x plus 2 we could write as x plus 2 squared. And then using the power properties of logarithms, we can bring down the 2. So 2 log base 6 of x plus 2 equals 2. All right, and finally we can divide by 2. So log base 6 of x plus 2 equals 1. All right, now we used the power property here of logarithms to combine this as a sum. We also might notice that these are exactly the same terms. So log base 6 of x plus 2 and log base 6 of x plus 2 would just give us two of them. 2 log base 6 of x plus 2. Okay. Typically the arguments, though, might not be the same. So we can always combine them this way. Okay, so here we have the isolated logarithmic expression equal to a number. That fits this form right here. And we can write it in equivalent exponential form. So this means that 1 is the exponent on 6 that gives us x plus 2. 1 is the exponent on 6 that gives us x plus 2. 1 is the exponent on 6 that gives us x plus 2. All right, and now we solve for x. Just subtract the 2. So x is 4. And we can check this in our original, and we should do that when we're solving logarithmic equations because of the rather strict domain for the logarithmic function. Okay, so we put the 4 in here. We get 4 plus 1 is 6, and log base 6 of 6 is 1. Again, log base 6 of 6 is also 1, and 1 plus 1 is 2. So this solution checks out. It is the solution to our logarithmic equation.